We're now moving on to the second valid form of inference from predicate logic, which starts all A's or B's the same way all of them start. That is, everything contained in the circle of all A things is contained in the circle of all the B things. Second premise, X is not a B. In other words, we have to put the X outside of the circle of B things. Well, if we see that that's the case, we know immediately that there's no way that this thing could be an A. So we know that X is not an A. And when we're looking at the analogous inference, modus tollens in the propositional logic, the pattern of inference, well, sometimes called denying the consequent, because you'll see in the second premise we are denying the truth of the consequent. Starts if P then Q, and here we have a diagram that all cases where P is true are cases in which Q is true, even though Q could be true in more cases. That's what that diagram is telling us. The second premise is not Q, telling us that Q is false. Well, in that case, since all cases where P is true are cases in which Q is true, that is, a circle of P true cases is contained within the circle of Q true cases, we can conclude that P is not the case, or not P. And let's look through an example as we did before with modus ponens, just to make sure we understand what's going on here. We have if P then Q, same diagram, not Q, therefore not P. And let's take an example of modus tollens, which might be if JZ is a mother, then JZ is a female. That is, cases in which JZ is a mother, the inner circle are all cases in which JZ is a female. Second premise is we know JZ is not a female. In other words, JZ is out of the circle. The cases where it's true that JC is not a female are cases outside of the circle. Therefore, JC could not be a mother. Now, let's take a look at the truth table. Here we have the truth table for if-thens. And let's take a look how we're going to figure out about modus tollens is a good form of inference. Well, we know, first of all, the first premise is if P then Q. In other words, if P then Q is true. So it could be the first case, the third case, or the fifth case, because in all of those, the conditional is true. But the second premise tells us that Q is not the case, or Q is false. So now we need a case in which both if P then Q is true, in other words, the first, the second, the third, and the fourth, and one where not Q is true. We've already excluded the second one, so it's got to be the fourth case. In other words, not the first case, because in that case Q is true. The third case, which had been live, cannot be the case because premise 2 tells us Q is not true. So that only leaves us with the last row. In other words, not P has to be true. And that is the idea behind modus tollens.